Okay, let us start with the arithmetic sequence and series. In our first question we have 5, 1, -3, and that pattern continues to -83, and our last term is -87. And it says write down the fourth term in the sequence. So we have the pattern of 5, 1, -3. So to go from 5 to 1, we subtract 4. And then from 1 to -3, we subtract 4 again. And if we do that one more time, we would find the fourth term is equals to -7. So therefore, the fourth term is -7. The next question says, calculate the number of terms in the sequence. We want to find out what is the position of the last term, which is equals to -87. Because it's arithmetic, we will use the equation Tn is equals to a plus n minus 1 d. Now a is the first value in the sequence, which is 5, and n minus 1. d is now -4. So if I multiply out, I see that Tn is equals to -4n plus 9. But we want to find out the position of -87. So if I transpose the positive 9, that will be -96 is equals to -4n. Therefore, n is equals to 24. The third question is, calculate the sum of all the negative numbers in the sequence. So we can see in our pattern that the first two terms are positive, and thereafter the terms are negative. So we have a new pattern. It starts at -3, then -7, -11, and it goes all the way to -87. Now, because we are ignoring the first two positive terms in the original sequence, we now know that the sequence of negative numbers only have 22 terms because the 5 and the 1 is taken away. So the sum of terms can be written as Sn is equals to n over 2 times 2a plus n minus 1 d. Now n is equals to 22. So it's 22 over 2 times 2 multiplied with -3 plus n minus 1, which is 21, times -4. And if I simplify, I have 22 over 2 is 11. And inside the brackets, it's -6 minus 84. And that is 11 times -90, which is -990. Our next question says, consider 5, 1, -3, and that pattern continues all the way to -4187. And it says, determine the number of terms that will be exactly divisible by 5 if -4187 is the last term. So let us write out this pattern. We have 5, 1, -3, -7, -11. And now the next term is -15, then -19, -23, -27, -31. And then next we have -35, -39, -43, negative 47, and negative 51. And what we can see is that term 1 is equals to 5, which is divisible by 5. Term 6 is equals to negative 15, which is divisible by 5. And then term 11 is equals to negative 35, which is divisible by 5. So in a sense, we have created or learned a new pattern, which is 5, negative 15, negative 35, and we continue with that pattern. So now we can use this new pattern, which are multiples of 5, to find how many terms in that sequence, the original sequence, is divisible by 5. So we want to find out how many of these multiple of 5 terms are in the sequence if this is a new sequence of terms which are multiples of 5, and how many of these terms do I need that will be bigger than negative 4,187. So now I use my new terms. So a is equals to 5, n minus 1. We don't know n, we want to solve n. And d, the difference between these terms is negative 20. And if I multiply out, it is negative 20n plus 25, bigger than negative 4,187. And if I transpose the 25, it is negative 20n is bigger than negative 4,212. And then I divide both sides by negative 20. And you would notice when we divide by a negative number, the direction of the inequality changes. Therefore, n is equals to 210. That means there are 210 terms in the original sequence that is divisible by 5.